Okay, everybody, today we're going to talk about reflection and refraction. The law of reflection states, and it's a little confusing, but bear with me, states the ray of incidence, the normal, and the reflected ray all lie in the same plane. What this means in simple terms, we'll explain that more in a second, but what this means in simple terms is that when a light ray is reflected, it travels in a straight line. It doesn't waver, it doesn't go up or down, it doesn't go side to side. It goes straight, and then the light that is reflected is on the exact same plane. So the thing I want to talk about before we discuss the diagram of reflection is you'll notice I've got laser being reflected by mirrors here, and it does go straight. But this light, the individual rays of light are going straight, but oftentimes most of the light that we're using in real life is going in many directions at once. So the law of reflection we don't see illustrated perfectly every time because there's so many rays of light. So it's kind of hard to see unless you're using like a laser or something. So here's what we'll discuss. Here's the diagram we'll discuss. So when they say the ray of incidence, they mean the one that's incoming. That's our ray of incidence. That's an important definition to know. So jot down a little note that that's what that means. So the incoming ray is the ray of incidence, or as they say here, the incident ray. Then it gets reflected, and it turns into a reflected ray. So the ray of incidence, the normal, and the reflected ray. The normal is the line directly in between these two. And what that means, what that sets up is you've got your angle to the normal from your incident ray is equal to the angle from your reflected ray. This is useful because then we can mathematically determine where light is going to go. So, like I said before, you've got a lot of light being fairly diffuse, which means it spreads out, goes in multiple directions. But these laser lights are the kind of thing that will show you more obviously that this is happening. However, it's still happening with a flashlight. It's just there's so many rays of light that and they're going in so many directions that it's more difficult to illustrate or more difficult to see. Diffuse reflection is a different type of reflection, but it's the one that we're probably more familiar with, although we don't know it. So oftentimes we'll think of reflection from mirrored or shiny surfaces. So if you walk into the bathroom in the morning and do your hair, you're going to be using a reflection of that mirror to help. But if that's the only thing that reflected light, then everything else would be invisible. We wouldn't be able to see because, like we've talked before, the light that's bouncing off of everything, that's reflecting off everything and going into our eyes is how we actually perceive the world around us through vision. So everything else would be invisible if everything except mirrors didn't reflect light. I realize this word is probably something some people don't know. Diffuse means to spread out. So diffuse reflection is when those light rays, instead of bouncing off and going in a single direction, bounce off of all those little bumps and different planes and different crevices, and they go in lots of different directions, and it spreads the light out. That's oftentimes why I don't know if you guys have ever been like in a car or in a classroom or something, and somebody's got their phone out or their watch, and it's reflecting light, and then they kind of like turn it, and it reflects light like right at somebody's eye. That would be an example of specular reflection, and that doesn't happen off of like the wall. You can't shine a light on the wall, and at a certain angle, it's blinding, right? And that's because all of the rays of light, although some of them are going towards your eye, a lot of them aren't. They get bounced around to different areas in different directions. So when a rough surface reflects light, it'll reflect light in many directions. And that's what we call diffuse reflection. That's our definition for diffuse reflection. Excuse me. So the uses of reflection, the everyday uses, are fairly obvious. Mostly it's mirrors, but there's a lot of different types of mirrors. So oftentimes we'll use mirrors to direct light towards our eyes from places we couldn't otherwise see. The most obvious in my mind is a car rear view mirror and the side mirrors. All of those funny little dentist mirrors that they like stick inside your mouth, they also use to see the inside of your teeth, right? Because they wouldn't be able to see that otherwise. And back, like way back in your molars. Bathroom mirrors to see ourselves, mirrors on a motorcycle on the handlebars, similar to a rear view. But mirrors can also be used to distort light, and we're going to get into concave and convex stuff. You've seen it before, we'll get into it in a little more detail. But concave and convex mirrors are useful for certain things. Convex mirrors in particular, like this one here, are useful for security mirrors. So what they're doing is they capture light from a larger area because they're bent outwards. So they're hit with more rays of light. And then once reflected back to us, we see a slightly distorted image, but we can see more. So those are really useful for, maybe you'll see them around corners or you'll see them in stores. So people, they can like see people shoplifting or like catch them shoplifting or something. And then they're also used for like safety, walking around a corner, you can see people coming around a corner. And mirrored headlights. I think this is a really interesting one. This is a good point. When you've got headlights on a car, there's actually a bunch of mirrors behind it. So when that light is on, all the light that's going backwards gets reflected forwards. So this is one where we're not actually distorting or changing the direction of light for us directly into our eye. We're changing light because we want to illuminate something, and mirrors can help us illuminate it better. And refraction. This is our other concept we're going to learn today. So refraction is when light, or any wave, but in this case we're talking about light. Refraction is when light passes from one medium into another. And what I mean by medium is like air or water or oil. These are all mediums that waves can travel through. So when light passes from one medium into another, and the direction of the wave changes, that's what we're going to call refraction. That's our technical definition. I want you guys to kind of know that one. But a simpler way to think about it is when light distorts or bends because it's passing through another substance. That's kind of how I think about it. But it is not this is not a technical definition. I don't really want you guys to write that down on like a test or something. It'd probably be acceptable, but this is a better definition. All right. And it's the same with reflection up here. This is the actual law of reflection. This is how I think about it. So I think it's always useful to know both of those things because I think I think the simpler language one is easier to remember. But it's important if you're having a technical scientific discussion or you're writing a technical paper or a scientific paper that you're using the proper definitions. Oh, here's my example. So the pencil, you've probably seen this if a pencil has been like a beaker of water or something, it bends, right? There's this point where it's going in straight, and then it bends over. Excuse me. And then for refraction, or for another example of refraction, this is the one that I see the most often is when you're drinking water. If you've got a straw, you put it in there and it looks like it's disconnected or something, which I think is pretty cool. And this is our diagram for refraction. You've got your incident ray, just like our reflection. So that's our incoming ray. And then as soon as it goes into this second substance, they just call it substance 1 and 2, but we could call it like air and water if we wanted. As soon as it gets into that second substance, the direction changes. It doesn't keep going in that straight line. And the angle of incidence, this one here, and the angle of reflection is this one here. And then we've got a refracted ray. I'm not going to ask you to do any mathematical equations for this kind of stuff, but you should kind of be aware that we have a very similar type of diagram that we can do with refraction. And I wonder, we should should show you guys this animal. I don't know if you've ever seen this one. I think they have some at the zoo. But there's an archer fish, it's called. So like this guy right here, this archer fish. Uh, they will. They're these type of fish. Oh no, went full screen. I'm sorry. They're these type of fish that have this really cool ability. These guys here, where they they'll spit water. They'll take water into their mouths and like make a little tube and spit water at like an insect on this leaf, and they'll try and knock that insect off and and then eat it. Right? That's how they like hunt basically. And one of the craziest things, like that's a pretty nutso thing, but one of the craziest things about this is I don't know if you guys have ever tried to like throw a rock at something in water more than like a couple centimeters. It's hard to aim. Like the because of refraction, because of the light that's going through the water and then through the air into our eyes, things are like off center from what you expect. But these guys have the ability. It's something with their eyes, or they can calculate it, or maybe they learn it. I'm not totally sure. Maybe they learn it as younger fish. But they're able to account for refraction and still aim accurately, which I think is really, really cool because these are just tiny little fish and they can do something that I can't do. Okay, your guys' assignment today is a research project around three questions that I think are important questions that everybody asks and most adults still don't really know the answer to. The first one is, why is the sky blue? People ask this question kind of in jest or as a joke, but it's because nobody knows the answer, or not very many people actually know the answer. So I want you guys to find that out because we're discussing light, we're discussing how light behaves and works, and it's a really pertinent question for that discussion. And the second one is what my brother's wife asked him the other day. She asked, "Can you ever actually get to the end of a rainbow?" And he gave her the correct answer, but she wouldn't believe him. And I thought, man, I bet you there's a lot of people who don't understand how rainbows work. So I want you guys to figure that out. And then, ask your parents or your brother or sister or siblings if you have any, if they know how a rainbow works and if it makes sense to them. And then lastly is, what are sundogs? So this is a similar thing to a rainbow, but you see them up here because sundogs are a little more common in areas that are a little more northern or southern, because oftentimes they're created by ice crystals. You'll see these a lot in the winter. So I don't want to give you any more info than that. I want you guys to check it out yourself. But each of these has marks attached to it. So the first two are 5 marks, the last one is 3 marks. That should roughly be how many sentences or pieces, important pieces of information you have. But there will be some flex on that depending on how you decide to structure your answers and such. Okay, everybody. Have a good rest of the day. Cheers.